hi everyone, thanks for having us along. We'll get kicked off with a couple of quick introductions. So my name's Dave McPherson. I'm an engineering manager in the Cache Cloud platform group. Within that, I look after a couple of teams, the storage team and also the developer velocity team. I've put a couple of ways to get in touch with me if anyone's interested as we go along. And my colleague will introduce themselves as well.
Hello, everyone. I am Karel. I am a cache engineer, a software engineer. I've been working in cache for the last 3 years, mostly focusing on scalability of databases. And you can reach me at LinkedIn, Karel-Alfonso.
Great. So we thought we'd actually start with what on earth it is that cache actually is. For most folks, it's not available. It's only available in the United States and the United Kingdom at the moment. So we thought we'd just sort of give you a little bit of a rundown on what it can do. So it's effectively a mobile cache or payments kind of system. You are able to do quite a number of things from direct deposits of money into it, similar to a bank account. You can get your own physical card, and you can get that in a variety of colors. You can even then do some pretty designs within the app itself. It lets you actually use your finger and create some interesting designs, which has led to some fairly interesting cards being created that are quite unique to the individual. Within there, you're able to buy and sell Bitcoin and also trade stocks as well. So something worth noting is you're able to trade dollar share or dollar portions of shares. So even if something's worth $800, you can take portions of it, which really feeds into sort of the whole concept and ethos of Square, which is to put financial tools into the hands of those who are more disadvantaged than others. So what's all that meant for Cache App, and in particular, our infrastructure and storage systems? Well, we've had what a lot of lovely people like to call growth up and to the right, and it's really lovely. The accountants love all of that. But what does that really mean for infrastructure engineers or platform engineers like ourselves? So we had a really lovely on-prem, because Square as a company actually predates the cloud. And so we had a lot of our on-prem data store in our original system. And so that was all fine. We just, as the load kept on going, we'd make the database a little bit bigger. And then, you know, things got a bit bigger and it got a little bit bigger again. And it was all going well. And then, oh my goodness, it was getting really, really, really big, and it wasn't going so well. So we ended up approaching these problems with a bunch of the usual approaches that people take. So things like putting in a large database. So a large database is great, but as a lot of you would be aware, and if you're not, you're about to find out if you ever scale, it doesn't scale in a linear fashion, the costs anyway. So when you go to a bigger database, it costs an extraordinary amount more, and you actually hit an endpoint in a number of directions. We were a little bit constricted in the sense that our system was effectively 3 monoliths pointing to 3 separate databases, which sounds great because you share the load around 3, but the reality was that all 3 were getting hammered as well. The way our queries were put together, I mean, in truth, Cache had spun out of a Hack Week project, and so a lot of the queries were not particularly well optimized either. Anyone who's been a database administrator or DBA knows all about those dastardly engineers and their terrible, terrible queries, particularly when you wrap an ORM in there as well. So we started trying to do things like break up the app, breaking it out into separate services, each of them with their own systems that, hold on, I should have turned off my notifications. Each of them with their own database as well that feeds through. And that's okay-ish. And then we also moved into using a tool or an approach or a system, an open source system called Vitess. So Vitess effectively wraps over the top of MySQL and allows you to create shards, which is great, really, really good, and certainly solved a lot of the problems that we had, particularly within our on-prem data centers as well, where we were able to actually install Vitess onto the actual instances that were running the MySQL daemons and work it from there. But one of the problems that we got was, or that is a built-in feature of Vitess, is that the transactions aren't ACID. So you can use things like two-phase commit, and the authors of Vitess even themselves recommend that you design it so that you don't actually have to use two-phase commit, which effectively removes ACID from that suite. Now, that might be okay when you're building an application out from scratch, but when you're retrofitting an application back in, it does become quite difficult. So it was going to require some fairly major refactoring of our application. Things like cross-shard transactions being either removed or managed and handled in a way that was less onerous on the system. This was very challenging. Every model in our system ended up having to require a shard key. Foreign key changes also had to occur as well. So the application had to become quite aware of the shards in order to avoid cross-shard transactions, which were very expensive, and actually was the main candidate for that non-ACID activity as well. So that was great. So we ended up with Vitess and sharded MySQL instances, and we started exploring getting it up onto the cloud because cache continued to grow. And to sort of give you an idea of where we've ended up now, from a little hack week project, we're now in the realms of 30 million monthly active users. We've got around 90% year-on-year growth. And anyone who's dealt with growth like that recognizes that it becomes very difficult to get ahead of the curve. You're constantly firefighting. You're often battling a lot of outages and things that break literally just under the heat of the number of folks coming in. As it turned out, COVID was a major kicker for us, as well, as we were able to pivot and work directly with the federal government in the United States and allow people who didn't have access to bank accounts in the United States to get access to the federal COVID funds directly into their cash apps, which was a great win for them and us, in the sense that it brought a lot of money into the ecosystem. It also brought an awful lot of traffic. So at the moment, in peak times, which is typically sort of Friday afternoon and Friday evening in the United States, and because that spreads across the continental United States, it really spreads those time zones. It means a good 12 hours on Friday. We're running at a very high load. Some of the peak queries per second can be around 2.5 million queries per second. Is a problematic metric, but regardless, the load is pretty high. At any given point, we've got around about 100 terabytes in transactional storage, quite a large number of shards wrapped over the top of about 1,000 different database instances. So that's sort of where we're at now. We were trying to move out into the cloud, which would allow the applications themselves to continue to grow more exponentially. We started to run into problems with Vitess, particularly in the cloud, and particularly with the decision that we made, which was to wrap it over the top of Aurora. So pro tip, maybe reconsider that. At this point, I'm going to hand over to Karel, who will carry on and discuss how we progressed from effectively Vitess, moved into the cloud, and have piloted out TiDB. Karel, over to you.
Thank you, Dave. Yeah, so in our case, as Dave mentioned, we were quite successful in managing to scale inside the data center with Vitess, but there were still issues. As Dave explained, Vitess across shards doesn't give you, or at least we weren't using, the two-phase commit approach that they provided. I think at the start it wasn't at a mature state, so we were using best effort transactions, and in the cloud we wanted to have a solution that was ACID compliant with minimum changes to our data models. We also found out, the decision of wrapping Vitess on top of Aurora instead of MySQL instances, which is what we had on premises, it didn't work as well, just because we needed to do certain types of configuration on top of Aurora that sometimes weren't compatible. We needed to manage parameter groups, and it wasn't as straightforward. We also found that, on premises, most of our product engineers have to have strong knowledge of the fact that the database that we're working with was sharded. And this implied not only configuring the sharding tables that they were using in their applications, but also knowing the type of queries and whether it was going to lead to cross-shard transactions or cross-shard queries, which were in certain paths that were of high load, a problem. We also wanted easier global indexes, which Vitess provided that as well. But for us, we required at times to backfill the secondary indexes. It also had to be configured as well. So we wanted something that out of the box would give us that. Another issue was a capacity. How do we scale as we go? And in Vitess, it's awesome. You can trigger a shard split, and you can split a shard into multiple databases, but you have to trigger that manually, but also you have to provision those databases by yourself. So there's a bit of overhead from an operational perspective in the process of scaling. We never tried merging shards. It's also a functionality that was provided. And on top of that, we were deploying all our services on Kubernetes. We wanted to be cloud native, having all the observability things in place to understand how systems were performing. We wanted also all the self-healing capabilities that you get out of Kubernetes. So we need to explore how do we keep doing this and improving what we're currently doing. Next slide, please. So we were already aware of TiDB. I think it came up, when TiDB was starting as something to watch out for. And we decided at some point to look at the state of TiDB and give it a go. We were particularly interested in the fact that it's a new SQL database, new SQL from the point of view of the global scalability. It's MySQL compatible, which is where our expertise lies. The fact that it's a hybrid transactional and analytical database, it was also quite interesting for us. So it's something that we wanted to explore more. But the most important factors were it was ACID compliant. The sharding is automatic, so we didn't have to trigger or provision new databases to do the shard splits, which was very time consuming. And you get global indexes. You can scale and shrink the cluster automatically as well. So we were happy to give it a go. Next slide, please. Just to refresh, I know Lishan already introduced from a technical point of view, TiDB. And I just wanted to show that for us, it was another big distributed system and something that we needed to learn. So we needed to get quite familiar with it. Just to refresh, you get application talking to a SQL layer, and you also have a storage layer, which is TiKV, and everything is managed by the placement driver, which is the cluster controller and manager. Next slide, please. So we needed to decide how are we going to roll this out, and it's not trivial given that we had already quite a bit of experience rolling out Vitess on premises. Both projects, the biggest one took around a year or so. We wanted to be careful with the product that we would choose to do this. So we decided to choose a service that had low customer impact. The latency requirements weren't that high, also the availability. And we picked this service. So it's a service that consumes asynchronously events from a topic in Kafka and publishes asynchronously to another service. So there's no customer interaction there. Next slide. So we decided to run some experiments. The first thing that we did was run load tests, benchmarks, just to get familiar at the start with the tool. This service that we chose, decided to set it up in a way that will consume from Kafka, taking shadow traffic from real production systems. So in this way, it would allow us to understand how this system will, when we decide to roll it out to production, what's going to behave. So let me show some of the learnings that we got from running this particular service in shadow traffic mode. Initially, we set this up in Kubernetes using EBS volumes. We had the option of using local SSDs, but we went with the option of using EBS because these are persistent volumes that survive across crashes. And we decided also to start with GP2 volumes, which it's a volume in AWS that gives you IOPS based on the size of your volume. And decided to look into that just to look at the performance that we will get without having to incur into much cost. What we learned is that we didn't get good performance from using GP2. We're going to talk down the track further what is being done to improve it, but we decided that to explore using IO1 instead. With GP2, we were constrained on the bandwidth in the volume. We were initially looking at IOPS, and that was a bit of an oversight, but you also constrain in your volumes by the bandwidth, the number of bytes per second that you're receiving. So we decided to use IO1 because you have double the bandwidth, and also you can provision whatever number of IOPS you require without having to depend on very large volumes. Next slide. Yeah, so in terms of the way TiDB shards the database, or TiDB sometimes says no sharding, but there's some sharding happening in the background because the data is distributed across nodes. All our services on premises are using MySQL, and all of them use auto increment. And I don't know if it was covered before, but when you use auto increment, the way TiDB shards the application using range-based sharding, it can create hotspots or hot shards if the write path has very high load. So we did run into this in some of our experiments because some of the services that we're planning on moving towards TiDB are synchronous RPC-based services that will have a higher rate of writes. And even this service that is taking shadow traffic in the future is going to consume from more topics that could have even higher traffic volume. So with auto increment, you can end up with hot shards, meaning that one TiDB node will get most of the writes. Even when there's some balance, region, there's a scheduler that is going to balance the regions and move the data across, but you can still, based on the load, get a hot shard. So if you're planning on using this approach, I think my advice is to run your own benchmarks for the particular workloads that you're trying to put into production and decide from there. Next slide. So TiDB, at the time, we're using 3. something version, and there was this option using auto random, which was experimental. And I think since version 4.03 is now available, so it's not experimental anymore. And what it gives you is, on the right path, it balances out the primary key IDs across all the nodes in the cluster, which is very great. It's good for the right path. The problem is what happens now when you try to read the data. Next slide, please. So we found, for instance, that reading from secondary indexes of key, let's say that we have customer and payments, and payments has a customer ID. So payments has its own primary key, which is distributed auto random. And now we want to find certain amount of payments for a customer. Because it's auto random means that all the payments for the customers are distributed across the nodes, which means that we need to do like a full cross-shard query. What we found is that for some plans, these created suboptimal execution plans. We've been talking to BinCap. There are some documented issues in these slides that track some of the problems that we ran into. But we did hit issues because of this situation of using auto random. So it set us well on the right path, but in the read path for certain types of queries, it was a problem. Next slide, please. So we discussed with BinCap, and there was I think like a brainstorm. These are not easy to answer solutions because we're in the presence of range-based sharding, which means that you shard based on the key range. And we came up with, in the discussion, the idea of using clustered indexes, which is prefixing the primary key, or essentially having a concatenated key where you have, let's say in our case, we want to chat, and this is how it was in Vitess, we want to chat by customer ID, and using clustered indexes, we can redesign the payments table, for instance, to have the primary key of the customer ID plus the payment ID. And in that way, if the index is clustered, we can have a situation on the right path where most of the rows for a given customer are in the same chart or the same region. And I'm loosely representing a chart here as a single, database, but in one single TiDB node, you're going to have multiple regions, which is the term for a chart in TiDB. But this is just very simplified. But the idea is that you want to have most of the data for your query access pattern to touch the least amount of servers or nodes. And this is a proposal for which there are issues already created in GitHub for that. Next slide, please. So let's have a look. We learned a lot through the months where we were deploying this traffic, this service using shadow traffic. We tuned the system and the configuration. I want to run you through what it looks like now from a metrics perspective. Next slide. So this is the application that is consuming from Kafka. And as I mentioned before, for us, the latency, even if it was in the order of seconds or tens of seconds, it wasn't a problem. So you can see, we managed to fine tune this so that we get it like 300 milliseconds. And this is for acknowledgement of messages to the topics, fetching, redeliveries. And we're currently consuming 1.4 thousand events per minute. Next slide. On the TiDB layer, we deployed in Kubernetes. Like I said, we have 2 TiDB nodes, 5 TiKV nodes. You can see the specs in there. Our traffic peaks during the day are currently consuming like close to 4,000 QPS, queries per second. As you can see, the P99.9 percentile for statement duration remains mostly under 500 milliseconds. We do get some load, and I think in this graph is the TiDB nodes, something we need to fine tune. Next slide. In the storage layer, and this is the EBS volumes, currently using IO1, so you can see we have like 20K IOPS, and the bandwidth is like 500 megabits per second. That's the default that AWS gives you. As you can see, we have like very low latency, mostly sub-millisecond latency in EBS volumes at the moment. And we're not fully using the capacity of the IOPS that we have provided, as well as the bandwidth. Next slide. So if I were to summarize, there are tons of things that we learned. There are lots of issues that we talked to PinCap and that have been fixed. But I just, in the context of this presentation, wanted to highlight the main ones from our point of view. We wanted more performance from our EBS volumes. As I mentioned before, we noticed that we don't fully utilize the IOPS that have been provisioned, and as well as the capacity. So there are some issues that are being tracked to improve on that. We also want collocating rows. So realize that regardless of, you can use range-based charting because it gives you, for the type of searches that you do in online transactional processing databases, it works really well, but you want to touch the least amount of nodes as possible, and collocating rows for certain query access pattern is still something desirable. There's an issue that is being tracked for that as well. We've been, wanted to call it out, very, very extremely happy with PinCap support. We have day-to-day conversations and fixing issues. The turnaround is really quick. We've also contributed to the open source project, and I encourage everyone to do so as well. And we were also happy with database migrations. One of the problems that we're having, even with Vitess and Aurora, even with our Vitess, is that when your database grows really large, running online schema changes takes forever. So if you have 1 terabyte database, then you're already getting the limit where you can do an alter statement and add a column or modify something. So if you need to rebuild the table, it takes forever. And in TiDB, it uses a protocol or an approach from Google. I think it's called F1. Most of the database migrations or line schema changes are applied on the spot, except if you are adding an index, which can take a couple of minutes. Next slide. So everything is awesome. So we're very happy with, we had it run into the expected issues. It's a brand new system, but we're very happy with TiDB where it's at. Next slide. I just wanted to give you, from an engineering point of view, my personal view on TiDB. For us, the journey is like you would expect. It's a fully distributed system. I like to sometimes show this quote from Leslie Lamport, who is a renowned academic in the distributed system community, where he says, you have a distributed system is one which a computer that you didn't know existed, can render your computer or your whole system unusable upon failure, and could be a computer or a process. And we saw lots of that. We saw sometimes scheduled backups killing the balanced region scheduler, and then it doesn't come back up again, which means that you keep putting traffic, and then all of a sudden your cluster is unbalanced and things like that. So it's been a whole, learning experience for us. We're very happy with the maturity of the product, despite all of this. It's a fully usable database. All the Kubernetes support is awesome with the TiDB operator. So we're using that with all the Helm charts with some configuration on top of that. TiDB gives you like very rich set of observability metrics. It's like sometimes initially when you don't know the system, you can be overwhelmed by the amount of those. And as you start learning the system, you start getting more familiar and understanding which are the metrics for different types of situations that you have to look at. So in our case, like the way we've approached this is like, we've been very, I guess, disciplined, to document in our runbooks every single learning, every single issue, and also document the metrics that are relevant in that case. So I encourage everyone doing that to follow that. Otherwise, it's too much information. There's quite a bit to learn. And as I mentioned, the database migrations, which has always been an issue for us. That's why we in Vitess or in Aurora, we say once you get to 1 terabyte, you start thinking about sharding. Currently, we have 2 terabytes in our configuring in our hard drives for TiDB, and migrations is not a problem. Next slide. The other thing for me, for being part of or dealing with PinCap and the open source community, I'm really happy with the support for us as a customer, the awesome service that we're getting as well from the company, and all the quick turnaround for all the issues that we're coming up with. And the TiDB documentation is excellent. Personally, follow the blogs as an engineer outside of Square. If you want to learn about distributed systems and some of the challenges, by all means, I encourage everyone to read the blogs.